So our next topic is on seismic load analysis or earthquake load analysis. Here the earthquake loads or seismic loads will be calculated adopting a procedure which is known as equivalent static force method. In this method, we will be replacing the inertia forces at various stories of our structure by equivalent horizontal forces that are proportional to the weight of the body and its displacement due to the shear waves that is generated by the earthquake. And here we will be following the BNBC guideline as well. So firstly, let us know about the base shear. Base shear is simply the summation of the total inertia force that arises from the body of a structure. So if a structural element is created here, so here we can see a structure. In each of the story there will be inertia forces, and the sum of those inertia forces that arises from each of the stories will be carried out by this base shear V. So base shear is simply the sum of the inertia forces that arises from each of the stories. Now here we can see the formula for base shear. So the total base shear will be ZIC by R into W. Here Z is the seismic zone coefficient. It will be provided in the BNBC guideline. From the BNBC guideline, there in BNBC guideline, the table for Z values are given. According to the BNBC 1993, we can see this is the BNBC 1993. This is the figure for that was provided in BNBC 1993. Here we can see the total Bangladesh map has been divided into 3 areas or 3 zones. So there will be 3 zone coefficient. So it is mentioned here that Z is equals to 0.075, 0.15 and 0.25 for each of the zones, which are 1, 2 and 3 respectively. Here I is the structural importance coefficient. It will depend on the structural type and the purpose of the structure. For industrial, for commercial, or for residential, or for other uses, the value of I or CI will vary. It is also mentioned in the BNBC guideline. Here R is the response modification coefficient. It is depending on the type of the structure, that the structure is composed of which type of element, either it is made of concrete or steel or others. So we will get the value of R in a table in BNBC as well. So the last one is W. W is the total seismic dead load. It is not actually only the dead load, it will also it is also the combination of live load to some extent. So let's see the formula in details. Here we can see the seismic zoning maps according to BNBC 1993, and this is a recently updated one according to BNBC 2015, which hasn't been passed yet. Bangladesh has been divided into 4 zones. So here we can see up to zone 4. So in order to calculate the W, we not only need to know the dead load of the structure but also some live loads. So here we have already seen that C, the formula for C is mentioned here. C is the numerical coefficient given by the relation. So the relation for C is given here, 1.25 S by T whole to the power 2 by 3. So S here is the site coefficient. It will be calculated, or it is mentioned in the BNBC guideline based upon the soil characteristics. That means what type of soil that area have, or the area is consist of. T is the fundamental period of vibration of the structure in the direction considered in second. That means t is actually the time period throughout which the vibration will occur. Um, so in order to calculate the value of t, we need to know another formula, which is ct is equals to ct into hn to the power 3 by 4. By this formula we can get the value of t. ct is actually the coefficient for different frames or different structural systems. Ct is equals to 0.083 for steel moment resisting frame, 0.073 for RCC moment resisting frame, and 0.049 for all other structural systems. Here we have Hn. Hn is the height above the base level to the level n, that means up to which story we are creating our structure. So the total height above the base level is Hn. So in order to calculate the total base shear V, we need to know Ft, we need to know Fi. So here Ft is actually the concentrated lateral force at the top of the building, and Fi is the lateral load that is going to be applied at each of the story level. That means the force that is going to be applied in each of the story level is Fi. In so the concentrated force Ft acting at the top of the building can be determined using these formulas. Ft is equals to 0.07 TV, where it is applicable when only the value of t is greater than 0.7 second, and if the value of t is less than 0.7 second, then we need to consider the value of Ft as 0. Now in order to get the value of Fi, we can sum up the formula as something like here, something like Fj or Fi is equals to V minus Ft into Wz Hj divided by Wi Hi. V is the total base shear. Ft, we can calculate Ft from here. Wj is the total load in each story, or total load in each level of the structure. Hj is the total height up to the story level we are calculating. So Wi Hi is actually the summation of all loads from all stories. So initially here Fi was the summation of load from all stories, but Fj is actually the load in each stories, that the shear load in each story. So here we have the table for the value of R. We know that in order to calculate the value of base shear, which is V is equals to Zic by R into W, we need to know the value of R as well. So here we can see the table for R. If the system is bearing wall system, then the value will be depending on the conditions given here. As normally we use moment resisting frame system for our structures, so depending upon the material we will get the values as well from here. Here is the table for site coefficient S. S is required to calculate the value of T. We had seen earlier that S is required to calculate the value of C. So in order to get the value of C, we need to know the value of S. So this table will be used to calculate the value of S. This table will be used to calculate the value of base shear V, and this table for site coefficient will be used to calculate the value for C. So depending upon the type of soil, the value of S will be changed. Now here is a problem given that here is the plan view, building plan, and here is the side elevation. So the total area can easily be determined for this structural system. For this structure, the earthquake load is being applied from left to right segment, left to right portion. Here we can see the use of equivalent static force method. Here we are asked to use the equivalent static force method to calculate the seismic load at each of the story of a 6-storied hospital building. So this, depending upon this type of uses, the value of Ci or I will be changed, and the location is also given in Dhaka. So assume the structure to be an ordinary moment resisting frame built on, so this is another condition to get the value from BNBC guideline, built on soil condition S2. So here is another condition. So from the type of soil or the soil condition, we can see here the table for different soil conditions. So for S2 the value will be 1.2. The carrying dead load is given 150 pound per feet square, and live load is also given 40 pound per feet square. So here we are asked to calculate the seismic load or shear load or lateral load due to earthquake at each of the story level. So we need to calculate these loads. So actually we will be needing to use this formula to calculate Fj, and multiplying Fj with the height of the story throughout which it's being acting, we will get the value of these shear forces or lateral forces due to earthquake. So let's see the procedure. Firstly, we need to calculate the base shear. V is equals to ZIC by R into W, and as it is mentioned that this building is going to be constructed in Dhaka, so for Dhaka we know that Dhaka is in second, that Dhaka is in this zone. So for this zone, according to BNBC 1993, the value is 0.15. The value of Z is 0.15. So we are going to use this formula with this value. So we are going to use this value 0.15, and structure important coefficient for hospital building is 1.25. It will be also can be located from the chart that will be provided to you, and depending upon the response modification coefficient for or ordinary moment resisting frame, depending upon this condition, OMRF system, and as it is made of concrete, we will be able to get the value of R. So moment resisting frame and concrete is given as the element, so the value of R will be 5. So we are plugging the value of R as 5. Total dead load is given as 150 and live load is given as 40. So the combination for determining W will be dead load plus 25% of live load. So from here we will be able to get the value as 160 pound per feet square. So it's given in pound per feet square, or so now if we want to calculate the total load, we need to multiply with the area as well. So from this building plan we can easily calculate the area. It will be 40, and it is 15 plus 15 30, and 20 is 50. So multiplying it with 40 into 50, we will get something like the total load 66 as there are six, as it is a six-storied building, multiplying with 6, we will get it as 1920 kips. Now, in order to calculate the moment numerical coefficient c, we know it is the formula for calculating c. So we need to know the s and t first. Here the soil condition or the site coefficient is given for S2 condition. So taking the value of S2 as 1.2 and plugging it here 1.2. So we plugging the value of S 1.2, and T will be calculated from the formula Ct Hn to the power 3 by 4. Hn is the total height. We can get it from the elevation given, 12 plus 50, which is 62 feet. So plugging the value 62 feet, but here in order to calculate the value of t, we need to convert it into meter. So in order to convert it into meter, we need to divide the feet with 3.28. We are converting it into meter. So plugging all those values, we will get the value of t, and plugging the value of t and s over here, we will get the value of c as well. So we can see the value of c is less than 2.75, which is okay according to our condition. So v will be equal to z into 1.25 into c divided by r into total load, which was calculated earlier, 1920 kips. So from here we will get the value of base shear. Now from base shear, we will be calculating the vertical distribution of lateral forces. That means the force that is going to be applied in each of the stories. So for that, we need to create this table first, but before that we need to calculate the expression for Fj, force that is acting per unit length, and then multiplying with the length along which the force is acting, we will get the value of lateral forces. So plugging all those in this formula, here we can see the value of V was calculated as 142.22 kips, plugging the value of V, plugging the value of Ft. So as the value of T is 0.661, which is less than 0.7, so according to our condition given, Ft will be 0. We had already seen this earlier, that if the value of T is less than 7, the value of Ft will be 0. So plugging the value of Ft here, and Wz. So Wz is actually the load from each of the story level. So we can see here that the load in each story was 0.16 kip per feet square. So 0.16 kip per feet square. So in each story, for six stories it was 1920. So for each story it will be 1920 divided by 6, which is 320. So plugging the value of 320 here and here, Wz, and Hj, we still don't know the height upon which it is acting, and plugging the value of Wi for each of the stories, and plugging the value of each of the story height. As we know that our first story, the height of first story is 12 feet, and the height up to second story is 12 plus 10, which is 22 feet. Height up to third story is 32 feet. So plugging those values respectively over here, we will get the expression for Fj, which is 0.641 Hj. So here we have already calculated the expression for fj, and using this expression we will calculate the force that is going to act at each of the story level. So if you draw the stories 2, 3, 4, 5, so 1, 2, 3, 4, 5 and 6. Okay, multiplying with the heights of each stories, the total height of each story will get the value of fj. So we are creating a table here, this table, so making 1, 2, 3, 4, 5 columns in total. So here we can see story 8j, that means the height of the story. For first story the height is 12 feet, and the height of second up to second story is 22, up to third story is 32. So plugging those values over here and then calculating wj. We have already calculated the wj in our previous slide, which was wj. That means for 6 floors it was 1920. For each of the story or each of the floor it will be 1920 divided by 6, which is 320. So plugging the value of wj, so for first story it will be 12 into 0.641, so it will be 7.69 in total. For second story it will be 0.641 into 22, so it will be 14.09. In this way we will calculate it up to 6 story, and then we need to assign the lateral forces. So we can see here that in the 6th story the force is 39.72. This will be 39.72. so now if we want to calculate the force for 5th story, the force only for 5th story is given as have been calculated as 33.31, but we know that in order to calculate the force in 5th story we need to consider this previous one also, as 6th story is been constructed just in the top level of the 5th story. So the total force that will be acting on 5th story will be 33.31 plus 39.72, which will be 73.03. Similarly for 4th story, that means this 4th story, the force will be 73.03. that means we have calculated it 73.03, and summing up those values, that means in 4th story the individual value is 26.91. so up to 5th story it was 73.03, so the total force will be 73.03 plus 26.91, so in total 99.94. so in this way we need to calculate the others as well, and finally we need to sum up in this figure that the force in each levels. So this was all for this lecture. Thank you.